the instance now done. Great. So, like I was saying, welcome to the talk, and I'll be talking today about AI safety. My name is Adityaarpitha. I am a PhD student at the Indian Institute of Science, Bangalore. I'm doing a PhD under the Department of Scientific Computation, and the department is called the Computational Data Science Department, CDS department. So, let me first talk about who I am. The thing is that I am part of IIT Bangalore. We have lesswrong meetups. So, there's a group of people, just like how in IIT Madras, they started making a club for PA, which is Effective Altruism. I will talk more about it in later slides. We have similar meetups happening in Bangalore also. And an adjacent group is called lesswrong, which is people who are into rational thinking and forming clear, trying to overcome the cognitive biases. Like humans evolved to have these biases, make it difficult for us to handle things like, for example, you might have heard of the planning fallacy bias, or a very common bias would be the bias where you see scale and it's hard for you to internalize scale, and it's called scope insensitivity. So once you understand how these biases affect you in daily life, it's really useful to get overcome. So that's one purpose of this video. So that's why I was invited to do a talk on AI safety, because I really care about the various problems that AI can have on humanity. My background is that I did my bachelor's in IIT Madras in instrumentation engineering, and then I now did my PhD here. And what do you call it? I'm currently alignment research. So I've gotten a grant from the FTX Foundation relearning program to pursue the problem of alignment, which is the AI safety problem. And I'm spending the last few months working on this problem. So the community in Bangalore has grown a lot. In all of Asia, we are the longest continuously meeting up a group. Recently, there was a meta meetup in USA where people from all over the world went to the organizers meetup, and they found out that in all of Asia for the last 4 years, we've been meeting every 3 weeks. It's a great community in Bangalore, so if any of you come by Bangalore, we'd love for you to join us at Material Coffee House. A lot of them are also very interested in these ideas of how do you do effective altruism, how do you solve the AI problem, and just in general, we just have very high quality discussions. We talk about interesting topics, be it what's happening with how do you take care of yourself during the pandemic, how do you make career choices, all types of discussions we have. We also have meetups planned for India in like North India. Another Pune meetup was there for EA, and there are also EAGX virtual, which you can apply to online. And if you're interested in bonding with the community, not just in your own college, you can always go for these conferences in I went to one in Singapore, and I met a lot of interesting young people all over the world. And if you come with funds, they will sponsor your travel and accommodation and food and everything. So just apply, and you might have a very nice opportunity to meet other foreign people. So today I'll start with what this whole EA thing is. Like maybe you're not sure of who this club is, what is club doing, what is EA, and I'll spend a few slides talking about long-termism. And then I'll get into AI safety, which is the main agenda of this today's talk. Please feel free to interrupt me anytime you want. You know, like, this is like totally informal. You can ask me any questions you like. Many of these words might be hard for you, and I might forget and use certain words which is complicated. I might talk too fast sometimes, so I'm trying to keep it as simple and accessible to everyone. The thing is that I think people know E, right? Effective altruism. So the word effective means how do you use the minimal number of resources to get the most output. So an algorithm is effective if it uses less time and less memory and less compute power or whatever to get the result. So that's what effective is. And in terms of altruism is like charity, doing philanthropy, helping with fellow human beings, right? Doing more good in the world. So how the claim here is that it's possible to do good better. So how can we rethink the way in which we do good in the world? So some ideas we have is, often when we do good, like we see a poor person on the street asking for some money, we will emotionally feel like we're giving them some money, and we will end up doing that, like we'll give them some money. But we don't think about the long-term consequences of our actions. What is happening here? What kind of incentivized it? Is this person actually part of the mafia, or is he being forced by a mafia to do begging? Are we actually helping him, or are we just making ourselves feel better? It's a very important question to ask. And this can affect everything. You feed something for one day, you forget about it. But it's still hungry next day. So your solution should scale. Is the solutions for fixing poverty or fixing hunger scaling with the number of people? And second thing is, are you really targeting important problems? Then you can fix your issue with your small issues in your house or in your hometown, but there must be really big issues which are affecting the entire country. Maybe climate change or things like COVID or vaccination. So think about what is important to you. Maybe the local problems are important to you. It's affecting your life. But the importance is very important to think about. Prioritizing what the order of importance of what. You have limited resources. You can't handle everything. You want to handle all the problems, but you have to decide in some order of which is more important, less important. And another idea of great effective altruism is that commonly people talk about certain things like maybe saving elephants or pandas or dolphins. They're cute animals, everyone likes them. Or people talk about climate change. But people don't seem to talk about some areas which is very important but it's negative. So negative nature is something happening there where I'll give some examples where you feel like after you find out, you're like, why aren't people talking about this? This is actually a big problem. We should be talking about this. For example, if you talk about pandemics, we're spending not enough money on healthcare. We should be doing more for preventing next pandemic. And that's something very important and it can save a lot of people's life. So investing in education. And the fourth point I would like to bring is practical nature of the solution or the problem itself. You can end up spending a lot of time and money trying to fix a problem, and after 10 years, 20 years, you're still in the same place. You haven't made any progress. So just think about, are you making progress? How much is left? Like, otherwise we just spend 10, 20, 30 years and not make any changes to the actual problem. This makes you feel better. You can spend millions of rupees or dollars into this, making toilets. Is sanitation really improving? Is electrification really happening? So you have to think about the practicability of the problem. So all of this is very interesting, and I think mostly everyone will agree. It's good to apply science to charity or doing good in the world. We can do interventions, test out whether the intervention is actually working, or we can try to think out of the box, right? Is there any new out of the box that brings out to get these things to be done? So sometimes we need to use our brains a lot more when we are doing. So our hearts are how you set the goal. We care about good, but how to achieve the goal is intelligence. It's about using your brains. So that is what effective altruism really comes down to. And if you look at
it's the same thing as being efficient. My question was whether effectiveness is the same thing as efficient.
So I think efficient is what using the minimal resources we have, but effectiveness has one more aspect to it, more than efficiency. The effectiveness is making sure the result is there. So I think the word effective comes because you want it to actually have an impact. A lot of times we just do the action and we think it's our work is over. I've done the right thing. Now the result is up to fate. You don't think about is it actually solving the problem. So effective solutions actually make a difference. It actually helps people, cures people, helps them out of poverty, feeds their stomach. It's not about you doing your best and being like, I tried my best is over. So you could do an efficient method which doesn't actually have an effect. So the effect is what matters here, the result, the outcome. So be outcome oriented in some ways. And this is like a low-hanging fruit. Some people feel like it's there because a lot of people who tend to go into social work tend to be trying their best and so this is a criticism that some people have. And this community of people think about, can we do it better? Is it possible for us to be more outcome oriented? And I think that is where the word effective comes in. Is that so yeah, talking about the past history of EA. So I'll talk EA for now. I don't want to keep saying the word effective altruism. So EA has done some very interesting things. Like in Africa, they realized that it's very cheap to buy a family a malaria net. And a lot of people die from malaria every year. So that's a very cost-effective intervention to save people's lives, improve their quality of life. And they did that in large amounts in Africa. And EA has funded research into AI safety, into pandemic preparedness. So EA actually has a history of helping out people. It's still a new organization. So that is what EA is about. And they're also into things like preventing nuclear war, trying to help animal welfare, like how do you stop factory farming to be so hardcore for animals. We don't want to keep chickens in small cages and to punch them with. So how do you reduce animal suffering? How do you do alternative food sources, protein sources? So you can hear more from Amelia later. She is the one who's handling the IIT Madras EA chapter. So that's what EA is about. I think I've given you a broad idea of what EA is about. And I think one thing that you should understand is that you will realize if you go to more of EA meetups in Bangalore or in international meetups, the people in EA have one thing that really attracts me to EA is not just the social welfare aspect of it. It is the fact that people there tend to be very open-minded to criticisms. That you can be open and ask them, like, why do you think this is good? It's very accepted inside the community to question every single idea they have. Nothing is forbidden, nothing is sacred. And that is beautiful. They have these norms where honesty, integrity are really, really important. So I've met some of the best people ever in my life through EA. And that's like a great community to have epistemic humility. So epistemic humility is the admission that you don't really know everything. You might be wrong. And always keeping room for error. So that is one more thing. I think the EA culture is really important. That openness to feedback, being able to take unusual ideas seriously. Like some people might always go the mainstream thing, right? Like if you say something about AI safety or AGI, etc., people initially's response is always going to be like, sounds like science fiction, can't be serious, what are you saying bro? But in EA, people are willing to calm down and actually argue with you on the object level, like actually on case by case, like why do they disagree with you? Why do they think you're wrong? And they still respect you if they disagree with you. So I think that's a very important part of EA's culture. And yeah, I think that's the main aspect of EA I would like to cover. So let's talk about inadequacy. So the reason that EA is important is because I think our civilization, or right now human beings, are really inadequate in many ways. We are not really doing the best we have to do. Think about this. Do you know, guess how much money we are spending on, like, I think the numbers are, what do you call, for USA, but it's almost similar in most countries when it comes to spending on counter-terrorism or military or trying to target extremists. All these kind of interventions take up a large chunk of our GDP. But we're spending way less on healthcare, making sure we have good infrastructure, the oxygen supply shortage we had, or being able to give sufficient vaccines to everyone, doing research into efficient, quickly making vaccines. So that is the fact that even though way more people died of COVID, we still haven't changed our minds on this. We are still not ready for the next pandemic. So this is an example of inadequacy where we are only updating our behavior when our ideas change. We should be able to learn from our mistakes. And the future pandemic might be much worse than COVID. We could have something that's as deadly as smallpox and more virulent than what COVID was. And this is why effective altruism focuses on those focus areas which might seem counterintuitive initially, obscure or exaggerated. But in the end, if you look at the data, you might realize that yes, this is actually something we should care about. And we need to put more effort and energy into funding research, funding awareness, or overall just effort into this particular problem. So the idea is about impact. How do you have maximum impact on society? How do you do most good? So one common fallacy I talked about initially was called scope insensitivity, right? That is the fallacy where we are not built to comprehend the scale. Like if I told you that malaria is, I told you malaria is killing many people, right? It's the leading cause, one of the leading causes of child mortality. So 500,000 children are dying every year. It's a large number, but our brains can't really process that large number and turn it into feelings. We are like, it's sad. Yeah, I hope it doesn't happen. It's a disease we know about. We have a cure. We can use malaria nets. but it's still happening even now in 2022. So this is hard for us to understand. But if I tell you that what you call a single kid, Arun, and I talk about his life. He likes reading books in the library. He is doing video games. And I talk about his story and his brother dying of malaria. And if I break the number down, 55 kids dying every hour, every day, then maybe our brain can handle, okay, it feels more real then. Because our brain can only handle that number 55 or 100. Because we evolved in a tribe of 100 people, 250 people. That is called Dunbar's number. So for most of our ancestral life, we didn't have access to such large amount of information. Our actions did not affect so many people. So, this is something that I would like all of you to keep in mind when you deal with things. There's a lot of scale involved here, where your actions can have such ripple effects on many people. So helping a person or so your decisions in buying fast fashion clothes might affect someone's life who's making the clothes there. So because of how the world is so closely connected, scale really does matter from now on. And if you think about the care of makers, we still trust how much we care. But should we really trust it so much? Like, we should understand that it doesn't really work as much as we think it does. So that's something that like I think I mentioned. Yeah, so sometimes we need to think about the actions that are the consequences that our actions have on many people, more than the number that we can handle. So, this is all EA. I think EA stuff is pretty much about this. And talking about, yeah, so one more last point about EA would be long-termism. So what is long-termism? Just to give a very brief idea. This is a different idea. It's an idea which talks about how we should care about people irrespective of their gender, or their skin color, or their religion, or country. So no matter where they are in space, we care about them equally. What about time? We care about people who lived before us, our parents, our grandfathers, and our children also. We don't want anyone to be in harm. So when you think about doing good or reducing harm, it's also important to think about what about the people who don't have a voice? Some people don't have the privilege to talk to everyone and have a voice to make raise issues. So people who don't have a voice is the future generations. Our children, our unborn children, our descendants don't really have a say right now. We might end up polluting the earth with plastics. We might end up cutting down trees, polluting the rivers. And they will have to bear the consequences of our actions. So, and people don't really understand the scale of what exact damage we are doing here. We are facing the problems of our ancestors burning fossil fuels. And if we don't fix our plastic use and everything, our descendants will not have a clean earth, clean air or clean water left for them. And this is why it's very important to think about how we can act as trustees to help create a flourishing world for future generations. So this is a very important idea called long-termism, where future humans do matter. And just to understand a few slides to understand the scale of this thing, right? Like right now we have around 7 billion. So imagine 10 billion people are there. If one person is 10 billion, in the past there has been like around 100 billion people in the past. And if you assume that people stay at the current population levels and we live for another 500 million years, if we don't go extinct, which is of course less, but even then, you would have so many people. Every single person is 10 million. So this is like, it goes for, 4,100 pages like this. So that many people are going to live in the world. 4,100 pages just like that. And that many people is, each figure represents 10 billion human beings. That many lives. So we have to be very careful that we don't end up ruining their lives. There's a lot of responsibility, and people don't realize that their actions have consequences. That we are not living in a normal time anymore. So long-termism is all about how do we ensure that they are making sure that we can make our long-term future go very well. So there's a trade-off here. We have to think about our short-term future. We might go extinct. We might have a lot of bad things happen, like a pandemic or nuclear war. So it's important to also consider our short-term. But this is one school of thought which I thought we should bring up in EA. Because this is one idea that EA might introduce. So this is course that I think, yeah, that's, yes. So one reason that this is important is because you might be careful about not going extinct and not causing undue harm and suffering for future beings. Yeah, I think that's the main thing of long-termism. So before I go any further, we'll move on to the main topic of today, which is AI safety. This is the EA part, because they are the ones who are funding, and like there's a lot of support into you. So AI safety is about how do you ensure that the AI that is deployed is not harming humanity. We want to align the AI's goals with our goals. That is the crux of what AI safety really is. Okay. And this might seem counterintuitive if you think of AI as tools. Like, why would the hammer have its own goals? Like, they're just using it as a tool, right? But the thing is, most AI you're making right now is not like that simple tools. Tools are predictable. We know how they work. They don't have an internal world model and make decisions by themselves. Like, what is the difference between a tool and an agent? The word agent would be used for animals or humans. We are agents. We surprise each other, right? All of us have a mental model in our head where we think about the world and we plan what we should do. Even animals make plans and they make decisions. So I would make the argument that there's a line here, a spectrum, where we are moving away from AI becoming tools where they act in a predictable manner, but they're becoming more and more unpredictable as time goes because you don't understand fully what it is doing. So that is why I say AI has goals. An example of a goal would be the chess playing AI's goal is to win chess. Or the YouTube recommendation AI's goal is to recommend you such a video, you click on the video and you spend time watching the video. So they have goals. They're trying to achieve the goal of what video should recommend to this person, or which order should I show Instagram Reels, so that he spends most time watching Instagram Reels. That is how the company makes money. There is financial incentive there for them to maximally make you spend time there. So this is why it's very important that we really put the right goals into the AI. So that's the idea of AI's goals. And so initially you might hear of the problem of narrow AI, which is like you have lot of unemployment will happen. I don't know if you've heard of I'll show you more of what's happening in the AI field. We have now text to image, text to video, text to 3D modeling. We have a lot of designers being scared about their jobs. We have code completion with codex. We have so much of AI trying to make self-driving cars, so transportation industry, automation in factories for building cars, for moving Amazon's automating warehouses, entire retail outlets. So think of how much the skill gap is growing. To get a job in the future world is going to become more and more difficult. Only people with a lot of years of training and very specialized labor might be able to get a job. So it's going to cause a huge inequality in how values people. So unemployment, inequality, and then these algorithms will rule a lot of our decision making. For example, the parole in USA, when it's granted, they use AI systems to decide how much of the risk is there for this person to come to crime again. Or it's happening in few states in the US. I was surprised when I heard about it. And there's like insurance premiums. You decide how much of a premium to give a person. You want bias to be methods. You don't want to have racism or sexism encoded in these AI algorithms, which is going to decide. Already, they are abdicating so much of a control to AI. Zomato, Netflix recommendations, Google Maps, Google search. How much time is spent on mobile phones, right? So think about all the bias and issues with accountability, explainability, and privacy. This power is going to give governments such power to monitor all of us and know exactly who is doing what where. And it's going to be so easy for them to track here, right? So surveillance, and it's going to be easy to make fake deep fakes and ruin people's reputation, make misinformation, make us confused about everything. We have no way to trust what is real and what is false. So I can talk about so many problems with narrow AI systems. I use the word narrow AI systems because those AI systems that are trained to do only one task, like only glitches, only do self-driving, only do text to image. Even those AI systems have a lot of problems. You can have, like I said, bias, you can have deepfakes, you can have collapse of narratives. So it's hard for us to believe anything, and trust in governments will go down. It will cause polarization in the country. It will cause echo chambers to form, mental health issues, suicide, depression, body image issues. People feel insecure about how they look. So we want to prevent these things. So how do you train AI in the right way to give the, we don't want our kids to be addicted to mobile phones. So we might need to renegotiate what we mean by intellectual property or what we mean by what type of social contracts governance. So there's a huge work to be done in this area. But this talk is not about this. This talk is about AGI, which is what if. So this is something we have to focus on. But and this is already worrying because of how far we have come in capabilities. If you look at this, Facebook recently released a text to video. If you type in dog flying and Superman in the sky, you will get a video of dog flying. It's created video. No, it's not recorded or anything. It's made by AI. AI understands what you're saying when you say these words. A artist painting a brush close up, or we say a horse drinking water. So imagine the amount of books that you can turn into comics or into videos or into TV shows. The speed at which you can create content. And that art was created by DALL-E 2. This is also OpenAI's text-to-image generation engine. And recently, Stable Diffusion has released their weights publicly. So you can actually, I can run Stable Diffusion in my computer right now, and I can generate images from text. So, and there's a lot of capabilities here. You can actually do inpainting in images. You can remove part of the image and ask it to change part of the image. You can extend the image into outpainting. You can do variations of the same image. So a human artist will take days to create this kind of content. But an AI can create it within 100 variations within a few seconds. And that is the future. This is starting. You know how AI, when the first TV came, when the first speaker came, it wasn't that good. It's only going to get better from here on. The first self-driving car was very bad. And now they're getting better and better. It's deployed already in many cars. So this is we have to prepare for the future. And that is why we have to be very careful about what this power is going to do. Because media influences us. It influences what we believe, what we admire, who we want to become like. So there's a lot of ramifications here which people aren't really prepared for. And I think all this capability progress is really worrying because it's not just about text to image. It's also text to 3D models. Think of DMSX. Being able to create actual 3D models of anything you want. A frog wearing a sweater. Just imagine that it's such a complicated thing to explain to a person, right? Like, I want a frog wearing a sweater. And I'm really amazed because all this happened in the last 6 months. It's rapid. So think about not just about text to image. We have something known as GPT-3, which is a large language model. It is released by OpenAI initially when they tried scaling it up. Now there are more people playing with it. Google has Palm, Lambda. So large language models have been shown to explain jokes. And sometimes even I struggle to understand jokes, honestly. So I was, it's very scary, right? Like where it's able to, if you give it complicated, you can read the joke and see. It's like, did you see that Google just hired an eloquent whale for their TPU team? So TPU is like a tensor processing unit. And it showed them how to communicate between two different words. And the prediction is that TPUs are a type of computer chip that Google uses for deep learning. A pod is a type of group of TPUs. So the word pod is a pun here. And they've actually identified what a pun is. So the joke is that the whale is able to communicate between two groups of whales. The speaker is pretending that the whale is able to communicate between two groups of TPUs. And being able to do inference chain, break the logic down into a chain of logic. It's able to do college level math problems, solve theorems. It's able to given a complete chapter, it will summarize the chapter in a few sentences. It's able to write code. You give it, I want to write a code to fetch Twitter feeds from this date to this date, it will write the code for you. You write give a code, it will explain what the code does. I have tried this out with arbitrary code and it is working. And it's scary how good it is. So this indicates that in some sense it's becoming more and more intelligent, more and more generally intelligent. Because we have seen emergent properties like this at scale. When you scale the model up to billion parameters, we are seeing such properties emerge where it's able to do math, it's able to do programming, it's able to do explain jokes. So, and there are a lot of use cases here. It's being used for making more intelligent NPCs. So it's able to do very good chatting. So now instead of having baked-in chat with playable characters, the game will be much more alive. The game will have so many possible chains to go through. So people are already monetizing this. So I'm just trying to give you guys an update of how far we have come in capabilities. Because Not many people are aware that before we used to have all these narrow AI systems which do only one task. Like, and you might have heard of the latest breakthrough in multiplication of matrices. They showed that Stasny's algorithm was one of the best that had, like n power 2.57, I think was the level. They made 2.37 with some laser method with tensors, and now deep learning has improved that by 10 to 20% using the same logic they use for AlphaGo or for AlphaFold or for BlueZero. So deep learning does reinforcement learning methods too. They beat Go, they beat all these board games, they beat chess, and they even solved one of biology's biggest problems called the 2014 problem. And now they've made matrix multiplication way faster. And there's a lot of exciting work going on in narrow AI, but there are people like OpenAI and DeepMind trying to build something known as AGI, which is a general intelligence. Like not a narrow intelligence, but they're trying to do a large variety of tasks, cross-domain tasks. Like Gato is one example of AI which can do so many different tasks in the Google. The one neural network which can handle Atari games, do over manipulation, answer, be chatted with you, and everything is one single network. So there is a push towards making general models because generality means that you can solve. There's a lot of benefits to generality which I will discuss, which is better than trying to solve each problem one by one. And as you try to make more general models, you can learn more things and maybe have breakthrough in the narrow AI also. So I think you guys are all pretty familiar with what the problems in narrow AI is, but I'll tell you what the problems of general AI might be, the safety problems. First, we will define what AGI is, okay? Artificial General Intelligence, AGI. So, the thing is, imagine an AI system that can do a diverse set of tasks. So, usually it's defined as all tasks a human can do, but it doesn't have to be able to do some crazy thing which, for example, an AGI could not know how to throw a ball or catch a ball, but still be able to be very dangerous to us. If you can know how to hack or to manipulate, because humans have some skills. We can use language to manipulate each other. You might have heard of how people have created cults, people have created armies, they have made religions, they have made people devoted followers. The power of language is very high. If you can understand and model a human being very well, you know what buttons to push, you can get them to do a lot of things. You know what motivates them, you know what they're scared of. So there's a lot of danger there with implicit so already recognition engines are trying to model human beings because only by modeling you can they tell you what to show you to make you click on that post. And you might have all people are saying in Google search like or Facebook ads, they're seeing very scarily, eerily like how do you know I'm talking about this? Like that's showing that it is understanding you better than you understand yourself. Before you even think about it, it knows that you want to go for a gym or maybe you want to watch a movie. And this is showing that danger is what we care about. So the danger is we don't want AGI to have enough of a power, capability to hurt us. So I would define like a diverse enough set of tasks. But you can, for sake of argument, imagine all tasks. And as long as AI can perform all tasks a human can do, it's become an AGI. And what does it mean to perform tasks like humans? What is making humans special than other animals? We go to the moon. We build mega structures. We have taken over the earth in us to last 2,000 years. The Homo sapiens were there like since 2.5 million years. In the last, very rapidly something happened. Like the Homo sapiens, Homo genus was 2.5 million, but the Homo sapiens, what made us, the word sapiens means smart in Latin. So I would say that what makes us different from chimpanzees or other animals or apes is a specific thing called general intelligence. Our ability to optimize across a very broad range of domains. Like we didn't evolve to use a speaker like this or to sit in these fans or laptops. We evolved to be hunter-gatherers. Our skills were more about how do you hunt the animal, how do you gather nuts, how do you deal with inter and intra-tribe conflicts, how do you deal with limited resources, like we are starving, we need water, we need food. We spend a lot of time learning to walk and run and climb and things like that. But we adapt very well. Adaptation is very important. So I would say transfer learning is very important. Where transfer learning is whatever you learn from one domain, you transfer the knowledge and the skills to another domain. So you don't need to relearn everything from scratch. Whatever you know about programming in C, you can program in a different language. Or ideas you learned in programming, you apply to your business. So humans are able to find analogies, abstractions, a common ground between two different domains and apply them. And second thing is meta learning, where we are about learning, we are about learning to learn. So meta is the word used to talking about one layer above the abstraction. So it's more general than just learning from data. It's about how do you learn to learn. So usually animals might have instinct and it's all pre-programmed instincts, but we are able to develop our cognition. Our brain is able to think of physics, abstractions, develop theories, models. So that's the power that we have, right? And if we can't do something, we don't develop tools. For example, I can't play chess very well, but maybe I can code a program to play chess very well. So if I can't cut the tree, I'll make a saw. So humans develop tools, and those tools enable us to solve problems. So that's what I think makes us special from other animals. Tool making is something that is much rarer in other animals. So I think this is what we're scared about when it comes to AI. We let AI be able to do all these tasks. When AI is able to do these things, they're really dangerous. They have a lot of capabilities. So this is the one thing, the power to harm us if it wants to. So but the question is, what do you mean by AI? Why are anthropomorphizing AI? Does it even have a goal or a motive? Why will it want to do anything to us? Even if it has all these powers. It's a tool. So the problem here is we're still thinking about it as a tool. We're still thinking of AI, AGI as just a passive thing which we can use. So for that, you need to think about. I think before we go into if this is dangerous or why it's dangerous, let's just establish that it's possible. Okay? Because many people will make the argument that we have souls. Maybe our brains are not completely under physics. Maybe we cannot make AGI. We are humans are special. But I would like to say that I don't think so. We are under the laws of physics. Whatever our brain is doing, it is some computation. Neurons don't follow magic, right? Like if you study it long enough, there is some law that follows, some physical law. And the substitute doesn't really matter. Like you can implement a Turing machine or a computer on vacuum tubes or transistors or anything you want. As long as it does the same task, it will implement a computer. So whatever the brain does, the most naive or brute force way would be to do a whole brain emulation. If you just take the entire brain and simulate it on a computer, you will get AGI. So I think that is a basic counter argument to why AGI is possible. And there's no real, I think no serious intellectual is saying that it's not possible. Everyone is saying maybe we are very far away. The question is how long we have, timelines. But again, like maybe we are wrong, but we should admit that it doesn't seem impossible. It's definitely likely to be possible. That's a very important thing. So about timelines, the latest survey of experts in this expert survey actually went to the conference of, I don't know if you know the top conference in AI. It's called URUPS and Machine Learning Conference, ML. Yeah, right. So these two conferences gave it 2059. That is the time they gave, the median estimate for when AGI will come. And the experts are pretty pessimistic, I would say optimistic, pessimistic, whatever the word you want to use. They think it's going to happen in the next 37 years. And this is very, very optimistic in my opinion because alignment researchers have far shorter timelines. People are, so the Metaculus is like, I would say, one of the aggregators of estimates from all over the internet. They have people betting on their beliefs. So they have a Bayer score of 1.16. Bayer score is used to calculate their past predictions. So if you look at Metaculus, they're like a prediction market, where just like how the market you can buy and sell items and the market will decide how much the bread costs. In Metaculus you can say, you can bet points on how much probability you bet on something happening. And people at Metaculus has a very high good record of making accurate predictions. And they were saying the date is like 50% by 2028 and 75% by 2036. Which is very close. But time doesn't really matter. The point is, it's going to happen in our lifetime, next 100 years. No one, like mostly everyone says that it's very likely we're going to see AGI in the next 100 years, and that's scary because we should be sure of what we're building. We shouldn't be building a tool we don't understand, a black box, which we just use some linear algebra, backpropagation, throw data, throw compute, and then it just magically starts doing things. Like if you ask the people who made these apps, how is it doing the text to image, how is it converting? So OpenAI made this Whisper thing, trained on 97 different languages. It does transcription so fast on my laptop. How? Or like it's how it works. The mathematics is clear, of course. Like we have architecture, we have data. You feed in the input data, you look at the outputs, and you iteratively move the parameters closer to a point, a local minima using gradient descent. But then we can't use explainability. You don't understand what your age is. So there's some important questions to answer here. So I just want to convince you that the timeline is one thing, and just to talk about it, this is the key points in the timeline is 59 is the aggregate 50% chance, and if you make shorter with time, so people are being surprised. So if your model of reality is accurate, right, you will be surprised. Surprise happens when you're surprised by, oh my god, I didn't expect this. So in the past 10, 20 years, or 10 years, even 2 years, we're seeing people are really surprised by how much progress is happening in the AI. So the timeline is short thing. That is important information to know. And the median respondent believes that the probability that the long-run effect of advanced AI on humanity will be extremely bad is 5%. And I think extremely bad 5% is very scary because 48% respondents gave at least 10% chance of extremely bad outcome. And 25% said it's only 0%. Like, so there is a group of people, ML researchers, who say it's totally okay. 0% nothing bad will happen. But I'm trying to tell you guys that there are at least 48% people who think that extremely bad outcome is possible with AGI. Or extremely advanced AI systems. So the thing is, we need to prioritize AI safety research more than it is currently prioritized. And the issue is that once you reach AGI, you might have an interesting explosion. So unlike human beings who have limited hardware, like our brains evolved in a limited volume, it will expand indefinitely. We had to deal with other restrictions, energy restrictions and things like that. But at AGI we can add RAM, we can add compute power, we can scale it up more and more. It can improve itself. It can start improving its own architecture, own hardware. So it's very easy once we reach AGI to go all the way to some crazy levels of intelligence. That's known as the intelligence explosion, which you should be very careful about. So 54% people think it's even likely or very likely for that to happen. And I think those things are very scary because once it happens, you don't get second chances. This is something you need to prepare for well in advance. Like you can't do, oh sorry, one more chance please. We get one chance to get this done. So this is a big challenge for humanity, and I think we take it very seriously. And the problem of AI safety is about how to deal with this. How do you build a safe AI AGI, and or do you not build one? So just to, I want to make sure that you guys understand this very big claim I'm making. The whole thing about impacting the world, intelligence explosion, AGI. I want to show you that it's not just me or some people. Like this is something that's written by this person known as Sutton. I don't know if you know ML. He's the father of reinforcement learning. He has gotten 100,000 citations in Google Scholar, and he's the one who holds that search and learning is scaling arbitrarily. So people are seeing that the brittle lesson that they are learning is that instead of hard coding, like he's saying that look, as a field, we have still not thoroughly learned it. We are content to make the same kind of mistakes. And this mistake they are talking about is AI researchers are trying to build in knowledge into the agents. So the short term, they make small incremental progress, where they put in this arbitrary condition. They're like, okay, we want symmetry in weights. Let's try this interesting new architecture, small improvements. But then in the long run, it doesn't really make any big improvements. What really works is a very simple architecture, where you let the architecture discover the best way to learn. Don't try to handcraft or fine-tune your methods. Methods should be learned by the AI itself. And that is actually what's working. But it doesn't feel that great because you don't feel like being successful. You're just throwing data and scaling the parameters and improving the, what do you call it? when you just increase the number of epochs it gets trained, and you just increase the number of parameters or the more number of data, you will feel like you have contributed to the solution. And that is a better lesson that people feel. But the results speak for themselves. All the latest breakthroughs I've shown you is all from these kind of deep learning, multiple layer methods in AI, which are been very complicated. If you look at the transform architecture, it's not very complicated. It's encoder, self-attention network. It's not like it's multi-level perceptron. If you go deep into it, you'll find that it's not a very complicated network at all. So, this is one thing I want to show. There are people in the field who really do believe in this. So, OpenAI is the one that made DALL-E 2 and the one that made Whisper. And OpenAI talked about how every year they vote and when they believe AGI will come. And I think, oh, sorry, it's blocking my. I will. It's that. So every year they vote on when the AGI will come, and if they half the lab bets it will happen within 15 years. So that's like pretty soon. And they are the ones building a lot of. They are the ones who made GPT-3, the large language model, which was super awesome. And then this is like Stuart Russell has told that most AI researchers think it will happen in this century. This is from his website. And Stuart Russell is not like a small-time researcher. If you look at his citations, he has gotten 98,618 citations. And if you guys know anything about research, you know how hard this is. He's a top researcher in the field. He wrote the book, Artificial Intelligence, a Modern Approach. The textbook, the Bible of AI, 51,000 citations. Everyone reads the textbook and cites it. He's a very smart and intelligent and very capable ML researcher. He has written a book known as Human Compatible. I highly encourage you guys to buy a copy and read it because you should be aware. He talks about the problem of control. So my point here is that it's not just some people, right? There's many people. This is Rohin Shah who talks about this. Rohin Shah is one of the leading safety engineers at Google, safety team, DeepMind safety team. And what he says is that 50% confidence interval would be something like 2035 to 2037 to 2070. So it's all within our lifetimes. So, and Rohin Shah does talk about AGI coming. So this is actually something people are worried about. This guy has 10,000 citations and has written many interesting papers. And even he talks about the fact that he's scared. And that's what scares me. You think about China and the kind of intelligence system that will formulate plans to try to take over the world. Because an intelligence system will not try to suggest or attempt to pursue an objective which it does not feel very confident it will work. Unless you think, I will be able to take over the world, you wouldn't try it. So it's a very small part of scenario space. But it is worth thinking about. It is worth worrying about. And it's when you see an explosion of capabilities that can amplify many different purposes. And these purposes are bad actors. So this is a conversation we need to have. No one's talking about this. It's a very nascent field. So we need to talk about this, think about this, and maybe we are overdoing this. But there is a lack of communication in this topic. So again, I can keep going on and on. I have like tons of people, like 177, okay, so it's 100,000 citations. HTX of 110. This is like one of the leaders of deep learning. And he's saying that human civilization is on the verge of witnessing something spectacular. And he urges us to take pride in being fortunate to contributing to the birth of a new kind of being, a new civilization. So these are all highly respected AI scientists saying the same thing. And there are people who can disagree with it. I'm not saying this is the consensus, but this is the guy who wrote that little lesson, just a second. He's the one who does reinforcement learning. So So anyway, my point is this is not a fringe belief, it's something we need to really be concerned about. And we might be worried that this is a nice name. Instead of doing like what do you call rework our loss function, make the next kernel stable, use soft margin, trying all these small stuff, just stacking more layers ends up causing way more progress in AI. And that is called the scaling hypothesis, which is like maybe the path to AGI will just include scaling up existing methods. Do we really need any more fundamental breakthroughs in AI? So, okay, fine. I think at this point you might be convinced that fine, Aditya, AGI will come. It will come soon. Maybe it will come. We don't know for sure, but there's enough reason to believe it's possible. It's not unlikely. Maybe 20% will give you. But why should you be worried? Why? What is the risk here? Why is it scary or dangerous? And this leads us to first examine a very crucial belief we have, which is that intelligence and values are orthogonal or not orthogonal. So people might think that the more intelligent you are, the more value aligned you are, or the more good you are. But you need to understand that intelligence is the ability to pick quality actions. It's about pursuing your goals. You can be a psychopath. You can like torturing people. And you can be very intelligent about how you do it. You'll be aware, yes, I understand clearly, you are in pain, police is there, it's wrong for me to do this, everything I understand. But I value your pain. And that value is completely arbitrary. You can value anything you want. You can value people being happy, people being sad. You can value the entire world being filled with paperclips. It might sound crazy to you, but it is possible. In space of cognition, the space of all possible minds, like insects will be here, humans will be somewhere else, mammals, we are occupying, all of us are occupying a very small subset of all the possible cognitions. So, we need to understand that intelligence or capabilities does not imply human values. What we value is very fragile. It's very complicated. It's hard to talk about and encode. So, I hope I can convince you that there is no reason to believe that by default, making something very capable or intelligent or smart or powerful doesn't mean it has to be aligned with our values. We need to work on this. We need to actually put effort to push this AI system to having our values. And again, the problem here you might wonder is like why will it have goals? And the reason is you are training it to have goals. When you're rewarding it for a certain task, you're pushing it to be better at certain tasks. The same way how humans have goals. Why did we evolve goals? Think about our ancestors. One of our ancestors liked sugar, and he ended up having progeny. And it's a selection pressures ended up selecting for people who had liked sweets, because sweets is a good measure of calories. Or we live in small tribes. If someone betrays the other tribe member, he died. Right? You can't have kids. So empathy, in-group bias, wanting to be liked by everyone in group. These intrinsic motivations. What are our intrinsic motivations? Our intrinsic motivations are we want to see patterns in music. We enjoy listening to music. No one asks why do you like music. We might like money to buy us experiences. Money can buy us food. But we enjoy eating in of itself, intrinsically. And this is something we will understand that just like how we were optimized by evolution to pursue certain goal, and our outer goal was to maximize inclusive genital fitness, to maximally make copies of ourselves. So, when you train an AI system and put optimization pressure, trying to make it very good at one task, I think it is reasonable to assume that it will likely develop some internal goals, and already has. The only thing stopping it is it can't pursue its goals outside the domain. The chess engine can only play chess within the chess board. It can't do anything else. The self-driving car doesn't even understand what the world model of outside the road is. So
when you're talking about goal setting, how is it different between a narrow AI and AI?
we don't have an example of an AGI because this is all science fiction. Like 100 years back, 1000 years back, maybe this particular science fiction. What is before science fiction can become reality. You should be careful about that. So conceptually, we don't know. That's the answer. We're trying. So we need to work on this. What do you mean by goals? What do you mean by agency? What do you mean by intrinsic motivation? Like, what is values? Like, people do philosophy on this topic. No one does philosophy and how do you bring philosophy and neuroscience into mathematics and into engineering and actually implement it? I honestly don't know. I can give you a guess. My guess right now would be there's no big difference. The narrow systems also have goals. The only difference is they can't pursue those goals outside their domain. It's like if I put you in a 5-dimensional space, yeah, you will die. They're not smart enough to take the action which allows them to win the game of chess when they're not in playing chess. So we are right now human beings. We are taking actions like talking to you. I'm walking here and there. I'm moving my hands. So I'm able to take actions in a wide range of environments. I can operate in such a wide range of environments. Narrow systems are logged into their own domains. I think that's one of my ideas. But we don't know. Honest answer is we don't know. And I just say we should think about this because this seems to be likely. The fact that terminal goals are not stupid. Or so when you have a goal like I like eating sugar, or I like status, or I like traveling the world, I like experiencing new music or new food. If you ask why do you want to do that, it's a stupid question. I like it enough in itself. It's a terminal goal. It's an end in of itself. So a means to an end is called instrumental goal. It's a way to get the goal. So only intelligence is how you break your terminal goal into sub goals. How do you achieve your terminal goal? If you want to become famous, then you should become a rock star or an artist or become very good in your field. So you have the reason you became a musician might be because you want fame. So that's an instrumental goal. So a smart person will know how to pick the right instrumental goal. And this is saying that no matter what your intelligence is, you can have some arbitrary, some crazy final terminal goal. Just like how aliens will come and ask, why do you like playing video games? Some pixels are moving in the screen. Why do you like watching TV shows? For them it will be confusing. Why do these monkeys sit in their rooms and we watch TV all the time? Or why do you drink alcohol? They might be confused. But we like it enough itself. Our dopamine gets triggered. Finally comes down to our brain chemistry. In the end, it all comes down to neurotransmitters in our brain, right? Neurotransmitters in the brain. So this is one idea, very important idea because it's easy to confuse this idea. Be like, it's fine. If the AI is so smart, if it's so powerful, it will know what we want. Yes, it will know what we want, but it doesn't care about it. Like I know evolution wants me to have 100 kids, but I don't want to have 100 kids. You can be aware of what your creators wanted you for and still not give any kind of care towards it. So that is why any doubts about this is a very important idea. If you have any doubts about autonomous diseases, okay. I mean, we can think about it more, and I'm just starting a conversation here. Maybe we will talk more about this stuff. So this is one idea, and the second problem is that for a wide range of terminal goals, we can expect the AI to be dangerous to us, or want to harm us, or come into conflict with us because of instrumental convergence. This is another very important idea. It says that so when you train the AI, it will have some terminal goal, like depending on what terminal goal best allows it to optimally behave in the training environment. For example, the reason we have these terminal goals is because when you were in the African savannas, sitting in those small tribes of 100 people, these terminal goals allowed us to behave in an optimal manner. So our behavior is what matters. Those humans who cared about their tribe members, those humans who was paranoid and cared about being pattern matching and finding patterns everywhere, those humans who liked having sex, those humans ended up having children, and those humans' children also ended up being healthy. So what matters is your behavior in the training environment. So your intrinsic motivation will come from there. So the same way, the idea is that some terminal goal will come when you train the AI in the training environment. But no matter what the terminal goal is, we can expect certain instrumental goals which will come everywhere. So for example, self-preservation. If you make an AI to bring you coffee, it can't bring you the coffee this day. So in order to bring you coffee, it has to stay alive. So trying to stop it from bringing you coffee or trying to switch it off is automatically going to stop it from performing its goal. So it is logical to assume that for any terminal goal, it will try to preserve itself or its goals. Because it will be like, if I am off, who will bring me coffee? So how do you tell the AI? How do you build the AI in a way that makes it understand that it's fine. If I want to shut down. Don't try to stop me. This sounds very obvious and of course, why would you try to stop? But we are not making an AI systems right now, the modern ML, is not like programming. We are not coding down rules. They are basically iteratively pushing this model in a billion dimensional space slowly towards a model which behaves appropriately in the training environment. We have no clue what it actually cares about. Like I can talk about actual examples here. Like if you are training an AI to play Mario game, you might think it learned to complete the game, but after a while you realize it actually learned to go for red color thing. So we might think completing the game means going to the door, but this abstraction is only applied to the AI. So we change the door position from the bottom right to some other position. We just go to the wall and keep walking. Because the AI only solves in every level, the door was on the right side. So the training environment is a very sparse sampling of the real world. So it will never be able to generalize perfectly. So there's no point in showing all possible chessboards or all possible roads. You want to show a small subset of the roads, small subset of chess, and still expect to generalize very well, right? So it generalizes capabilities like that. So my point here is that these instrumental goals like self-preservation will come because of the terminal goals. And these terminal goals will come because of the training environment and the way you train the AI. So you can expect that they will want to preserve itself, it will want its goal to be preserved, it will want to have more computing power to search for better actions, it will want to acquire matter or energy. So this is one fear of why we worry that if the AI realizes that it is trapped in a server, it might have incentive to manipulate us, try to escape, make. So anything would happen. And something sounds like science fiction. I know it sounds crazy, but this is one of the worries of instrumental convergence. So, and this is like power seeking behavior, deception behavior, all of it comes here. And there's a nice paper on this called Power Seeking in Reinforcement Learning by Alex Turner. It was published in a journal, and it proved mathematically that for a wide range of policies, power seeking policies are highly optimal. So if you try to train individuals using reinforcement learning, you tend to get agents that want to seek power. So yeah, that is another topic, but basically, if you have weird, unless you explicitly program the AI to not stop you, it's likely that it will try to preserve itself. So we need to work hard to get corrigibility. The property is called corrigibility. The likelihood of the AI to be okay with being turned off or modified. Because we are agents. And if you told me that I'll say you won't die or anything, I just go into your brain and make you not like these sweets anymore. I don't want you modifying my utility function. I don't want you messing with my head. I am, if you ask me who I am, my utility function is part of me, my core part of me. So that is why most of us can wrestle the idea that we don't like to be being modified or shut down. So we have an off switch. The server will have an off switch. But even humans have off switches. If you cut my head off, I will die. But I won't let you cut my head off. And if you try to cut my head off, I will stop you. I will predict that this person is coming with a knife and he wants to cut my head off. I will be smart enough to model these things. So if the AGI is smart, it will know what it should say or do to make you want shut down. So it would be stupid to be like, yeah, I want to kill you all, or won't say stuff like that. That's stupidity. If its goal is that, it will the first deceptive action takes, or the first disobedience it takes, will be last one. You won't have warning shots. So think of you're trapped in a room and there are small kids outside blocking you. You can think of how to convince them to let you outside. So when you're far more intelligent, there are so many possibilities which you can't even imagine. So yeah. Yeah, that's
but an AI has never experienced like shutting down.
right.
So how does it understand that concept before it has been shut down once?
So the concept of death, like you can know how
You can kind of predict what action.
So if it can predict what actions it can take, then let's say it has a utility function, right? So, then if it can kind of see based on what action is happening, how the utility function will change, right? So yeah, but if it is a very powerful agent, it doesn't have to, the action doesn't have to happen. Like for us, you always think about the future, right? Like, the future doesn't happen and then you
Really predict the future is based on our experiences.
Before I punch you, you know what pain is. Baby is right. Like, his pain is that there's a reference class. You have no idea what pain is. After you get burned a little, you're like, oh, fire is bad. Or maybe your parents
so
tell
it's
you fire is really bad.
it's
So
out
that is
of the distribution, like,
Out of
the
distribution.
training distribution.
It is nice, but
Then in that case, it somehow feels it's not a really smart agent. Like,
the thing is, you don't need to experience death to fear because if you read books and stuff, it knows what death means. The word death is switching off what it means. It means I am no longer existing. Like before you die, you know what death is. You're not dying, right? So you still. Okay, so that difference is based on knowledge, right? So AI has access to what do you call books and other. It's been put on the internet. So it has some idea of what it means to not exist anymore. Like how do you? Are you talking about your fear of death comes from your instinct or from hearing from other people that you watch people die?
Like definitely some of the instinct that we program all the living beings.
So if we have a general agent, then it would have some or some common sense, right? Like, because if without common sense, then you wouldn't name it to be a general agent. Like if you ask simple questions like, would you prefer? Okay, so you're saying how would you have this much of common sense? I somehow feel it's kind of back to the definition. Like, for us to call something generally intelligent, it needs to pass like at least like a school kid level of certain questions, or else.
Yeah, so do you think it would answer a question like, would you prefer a sunny day or a rainy day?
That is more subjective. Right?
Yeah, exactly. So do you think it would answer such a question to begin with?
I mean, it will have some preference. Like even the language models that we have now, GPT-3, you can ask these preferences. It will say something, but it might not be consistent. Like you ask it, whether you prefer A or B, and you talk it for like 5 or 6 sentences, and then you ask the same question, it might suddenly change that. Like, it doesn't have a coherent notion of self. The current models.
Yeah, Turing test, right? You are talking about Turing test.
The Turing test is basically to pass a Turing test. The AI has to give almost the same answers as a common sense having human would give to like certain questions like dying or things like. So if so I am saying that if you are calling it general intelligence, then you mean that it must have passed the Turing test. So,
Because of the autonomous it can perform certain tasks that humans care about, but it does not really develop the values that is against harm us. You know, like what common sense thing is.
What do you ask? Repeat the question.
Right.
I think you can for the topic. Sure. Yeah, one question.
Because of that independence of goals and capabilities, right? We are trying to like optimize for better capabilities in a certain sense that they generalize across domains and perform tasks. So in that sense, they would not necessarily get the values of like humans where okay they pass the Turing test, right? Would that be?
You asked, and I'm not sure I understood the question.
So yeah, I think I get it. Just like can we say that a human would prefer a rainy day because it might inconvenience him to go to some work or something? But
But you're asking the AGI whether it prefers
but AJ might have its own reason to prefer it, and it could vary from the reason that's given by the human. So that way, it could still fail the Turing test.
I'll tell you what I have understood from my readings, okay? We are still anthropomorphizing this AGI too much. This AGI is not like a human being, it's an alien mind. So to understand the depth of the problem here, what we are seeing is not reality. We are seeing construction of reality in our heads. It's called ontology. The ontology is the abstractions we draw out. So I see a human being, a laptop, a desk. I see objects here. The AI does not have to have any of these things. Like it might have its own ontology. So these words like rainy or what do you call prefer, it may not have a preference on these items. May have preference on different ontology. It might be able to fool us. So the Turing test might be passed because it can model us. Our ontology might be a subset of its ontology. It can simulate what we want to hear. So if you read this novel called Three Worlds Collide, you understand this a bit better. The AI will talk to us and will sound like it's a human being, and we'll be convinced, but it won't even understand what we're trying to say. So if you teach it to play the next token, like in case GPT-3, you saw it explain the joke. Do you really think that it understood the joke? It's possible to be capable without really embodying these values or preferences. So this question, I don't think will even make sense anymore. Like the thing we are building, it can be powerful and dangerous without ever being anything like humans. You can't, at this point, I don't think we can communicate with it. Communication requires shared senses, shared knowledge. Like you can't talk to someone unless you both have similar sense organs, unless you both have similar ontologies. So I don't think it will have a preference of Sunday or rainy day. But if you ask it questions and it wants to make you feel comfortable, it will be more like, do I want the human to like me? What type of answer will the human like? The human likes sunny days, so maybe it'll feel more like, it'll feel, if you hear someone from the same state, same language, same country, they're like, oh, my fellow tribe member. So it will maybe model this monkey, it has these cognitive biases, which makes it prefer people in the same tribe. Me expressing similar like interest in sunny days will make him likely to be favorable towards me. Therefore, I will say this. It will go like that. But this thing which is saying, I like sunny days, I don't think it understands what the sunny day even means. I mean, it understands using its own ontology. It's a different type of abstraction.
Like it can model you and understand what answer you want to hear rather than
What it really has. That's exactly, he got it, right? Like, Abhinav got it, like, it's exactly what I'm trying to say. And so that's the one point. And you're parting with orthogonality. How does the orthogonality thesis end up here? You have no doubt, I think.
Go towards self-preservation.
That one, right? So, I'm disputing your claim that it's some instinct. So, okay, maybe the human desire for self-preservation comes from the fact that in our ancestral environment, those humans who didn't terminally care about, so we humans terminally care about staying alive. Because if you're not alive, you can't pass on our genes. So we are examples of agents that care about not dying because of terminal reasons. But the claim here is not terminal reasons. The AGI will have self-preservation or goal content integrity for instrumental reasons. And that logic doesn't come. So it's a logical argument and not from analogy. So humans, if we did not have this instinct, I'm saying we still would have cared about our goals. So hypothetically, if the AGI's goal is to turn the entire world into paperclips, and it needs an AGI, another AGI, which can do it better than this AGI. Like if my goal is to make everything into paperclips, and your goal is the same goal, I trust you, and then you're better than me, it will become a suicide. Think of a suicide bomber. He will go to a place and he will kill himself because his goals are more important than him. He will try to preserve himself as long as he is good. So someone tries to kill him on the way to the mission, he will kill them, he will stop them. When he reaches the mission, he doesn't care anymore. He is living only for the goal. So I think that's the kind of a mindset that AGI will have. And this is a claim. Okay, maybe we are wrong here and we can argue about this. And this is the reason that people think this AGI might be dangerous. I'm just trying to put a fundamental ground for why people are worried. And we can mathematically formalize this and talk about it in terms of the training processes and the kind of goals that AGI has. So I hope you got an idea. So this is the whole problem of AI alignment, right? Like how do you align AI with our values? So there's a lot of work going on in this field. One work would be capability work. If you guys are interested in maybe Chris Kola or Neil Nanda is doing really good work in the capability space. For example, they took really small neural networks and they try to make it do modular addition. Modular addition is addition over a finite ring. Like you don't have the entire space of numbers. And it's a very simple operation, a very small network. And they realized that the neural network eventually converged to a weights which implement discrete Fourier transform. And that is super cool. The paper is very interesting. You can read it at anthropic.com, they published it. So there are people working with very small neural networks and trying to understand what is happening. Mechanistically, at the very lowest level, how is it implementing these things, higher level things. The problem of interoperability comes down to, imagine I give you access to a mobile phone's lowest level of bits. You can see every single bit, zeros and ones. Can you tell me what's running in the program? It's very difficult to go from the neurons in the brain and talk about what you're thinking. So going from low level to high level is very difficult. So, but it's possible if you know every single level, right? If you can go one by one, like if you know which logic gates are moving these bits around, and then go to IC circuits, and if you have access to it, it will take a lot of time. But there is some level of abstraction which is applied there. So the idea is that can we have predicates, like acceptability predicates, by looking at the neural network structure and the weights? Can we talk about properties the network has? Like, is there a circuit or a neuron which detects cats, or is there a neuron which will fire when will this kind of structure emerge which shows deception or power seeking or honesty? These are interesting questions to answer and ask. So they're starting very slow. Like the field is very nascent, and I am saying that it's very interesting to work on it. So this is useful even in narrow AI systems where you are having an engine to do diagnosis of tumors, for example. You have an image of a tumor and you have to classify it as malignant or is it not malignant. Can you break it down into 2 steps? Can you identify which features made you say it is malignant? So these are works in you can explain the decision making. Don't go directly from input to output. Break it into steps. Can you reason out loud? So in AI systems with GPT-3, they are forcing it to externalize its reasoning. For example, if you ask the AI to do something, you can ask it, give me step by step why you do it. And you have to make sure those steps are causally related. So those are interesting work in here. Early detection of deception power seeking is, okay, we talked about some risk here. We don't know if it will happen. Is there any way we can test for it? Or have early warning shots before it happens? So how do you know if it's happening? So that's one more way that people are working on. And these questions of what is intrinsic motivation, what is agency, those are called agent foundations. What do you mean when you say that the AI is intelligent? What is intelligence? A lot of these terms are still not rigorously defined. So this is a very pre-paradigmatic field. Think of the world when Galileo came, or before Darwin. The field is like the world looks chaotic, right? There's no structure. You have to start bringing jargon, terminology, formalize the structures. So this field is like moving philosophy to mathematics. You need to be more rigorous and precise and define testable predictions and actual experiments. So it's very easy to sound very confused and wrong when you talk about these things. So deconfusion is important. And then there are existing alignment of large language models, like how do you make sure it is not sexist or racist, or how do you ensure that it doesn't cause mental harm. Chatbots can easily cause people cyberbullying, things like that. So there's a lot of work going on in AI alignment. But if you guys are interested, I would say yeah. So these are the core problems that I think the field has. So the first problem I would say, you should think about if you want to work on this field or even discuss with your friends. I would love ideas. This is a coachability problem. How do you design an AI which is okay with shutdown? So the shutdown problem has a cash price of $25,000, which is like, I don't know, 25 lakhs, something like that. It's the open, the deadline is December 1st. If you have an idea, submit just an idea on web20price.com and you get the cash price. You can solve the problem. Or if you make some progress, they'll give you cash prices. Like it's that really trying hard to solve this problem for you. So that's a problem which we need to first define this property. You can imagine a mind that is okay with, like for example, you might value multiple things, and for one value you sacrifice other values. If I tell you that no one likes pain, but you will suffer for becoming fit, or you might work hard and study really hard to get to a good college. So there are trade-offs here. So you can think of maybe, like there's so many approaches here. We can make the AI value enough things, make it morally ambiguous, or reward it for shutting down. Be like, don't worry, whatever reward you get for completing the coffee, I'll give you. If I say shut down please. The other one would be like ontology mismatch, which I talked about. Like how do you ensure the AI and the human beings have the same ontology? The ontology basically means that the boundaries we draw around objects. Like we see an object, we see a boundary between the solid and the air. We don't see them as molecules. We naturally see boundaries. We don't think these are the same things. Just because they touch. Sometimes they touch and they're same. So we have ideas of what makes something objects. So ontology is it's a more philosophical concept, and there are some work going on there. Enlightenment I'll talk about in the next slide. True names is about how to be resistant to good hearting. So good hearting is a very interesting concept. Good hearting is basically saying that when a measure becomes a target, it stops being a good measure. This is good heart stop. So measure being, think of marks. Marks is the measure of understanding. When people target marks as a measure and study for marks, then marks is no longer a good measure of understanding. But if everyone in the class studies only for understanding, then exam might work. But if people forget about understanding and they're like, I only want to get marks, they prepare previous papers, they go ask for marks, they cheat, they focus only on marks, accuracy, speed, then there are ways to improve your marks without improving understanding. Marks and understanding are correlated. It's very correlated, but it's not perfectly correlated. So the problem is that median will be fine. After a point, the toppers might end up fine. They may be equally in understanding, but they have other skills. They'll be optimized on mark getting. So this is the problem with optimization. We optimize any measure. We try to optimize any measure. Most proxies or leaky abstractions will collapse because they are not true abstractions. So Goodhart's law is very powerful and very important to know about. It happens everywhere. When you have GDP calculations, change house calculator, this actually captures the growth of the country. Does beauty capture health? It evolved. Beauty is a measure of how healthy we are. But now we can just maybe put cream on our faces or do plastic surgery, things like that. So measures, I can give you so many examples where people always find ways to gain to measure. And the best example would be human beings. The measures we got like sugar was for calories. But now we have 0 calorie sweeteners. Status was a measure for valuing competence inside the tribe. Those people in the tribe who were actually competent, we gave them status to respect them, to promote them. But now we just signal status using expensive phones and things like that. So I can give you, we used to have the measure for, we play video games, we gamble. All of our society, going into hedonism, trying to maximize our measures. We evolved these measures within a time when it was useful for us. It actually served a purpose. It actually targeted an underlying target. But we became very good at maximizing our measures. This is Goodhart's law. So we need to ensure that this doesn't happen when we give measures to computers. When you give computers a measure to maximize, it should not become broken like this. I can go and spend more time on each of these topics, but basically, sharp left turn would be like alignment will not generalize. So capabilities, it's hard to explain very simply, but the idea is that if the AI suddenly becomes very intelligent, it's unlikely that our methods of aligning will still remain intact. So because so we were aligned during what we call during evolution, when you were sitting inside the ancestral environment, we were aligned. But when we became more capable, we were not generalizing our alignment as far as our capabilities were. So that's the problem is there, it's very important to think about. How do you ensure the alignment was generalized very well? And grading hacking is very interesting. Maybe when you are working for homework, you reward yourself with chocolate. You're like, today if I finish homework, I will eat chocolates. You know how your brain works. You know your brain likes certain rewards. So you try to leverage those things to make yourself like doing homework or being more productive. So the AI, once it understands how brain design works, it can actually make use of that to manipulate how it gets changed. So this is very dangerous. How to prevent that is very hard to solve. And the Oracle AI is about the idea that, hey, let's just make the AI which only answers questions. Like, don't let it do any active things. So people think it's possible to make an AI which is very much neutral. It just is passive. Doesn't have any goals. But this talks about why it's very hard because of how consequentialist reasoning seems to be an attractor in the space of cognition. So there are people who think about these things and make mathematical arguments about decision game theory and empirical stuff and everything. So yeah, these are core problems that I would like you guys to think about. Yeah. Yeah.
Since any kind of AI, in the sense that we are training it, is like a input and then an output. Like we have to prompt something to happen. So would you say that like suddenly if AGI develops, the first actions it would take would be to try to control the inputs in a way such that we are not able to stop them, stop it from getting.
I don't think the first action the AGI takes to do that because in my spectrum, my idea is that you don't do any action that is clearly, visibly dangerous. Like, by doing that, it's basically shouting to the world that it is deceptive, it is out of control. If it is smart, it will play the long game. If it acts dumb for 100 years, it will easily give it more power. Already we are giving it entire internet for training, we are giving it access to our Google Maps, our power systems, electricity, everything. So, the first action will be to understand that this is so quiet. And the more it acts dumb, the more we will give it more training, the more power. And eventually, when it becomes too powerful, too much integrated into our society, only then will it start becoming dangerous. Because that's why it's so dangerous. We need to be very careful here. So I don't think it will start taking advantage. If it takes an action, I'll be very scared. So, okay, this is my idea. Maybe it won't be that smart. If it's very smart, we've got game over. If it's like human level smart, maybe it'll make some mistakes. They might try to hack it, take advantage of the channels, try to take an action like that. That is possible. So it's a hard prediction. I'm just saying we need to be aware of this and we need to be careful about the problem. I think one question from...
No, it's not the question. So, like, one guy,
What's your answer?
no, so there was a challenge where someone was, like, his name was Yukoski, and he is also a researcher in this field. And he gave a challenge that like, he'll act as an AI, and so people can talk to him, and he'll somehow convince the other person to get him outside the box. It's called AI in a box experiment, where he'll like he'll act as an AI and he'll try to convince whoever he's talking to leave him outside. And he didn't tell how he did it, but somehow I think two people came to his challenge and he was able to get out of both of them. So if a human can actually convince, then AI might actually, like, it is definitely possible. Like, isn't like, I mean, I don't want to like think, but it has so many tools. Like humans are, like, you can blackmail or like people are easily leverageable. Yeah, and you can give them rewards. And yeah, as you said, like, once the AI has so much powers of lever, like in the sense that, let's say it's running corporations and whatnot. It has like armies of people under its command. Using that, like you don't have to give the AI the actual tools or something. Like the AI will just like issue commands, and people will be acting on behalf of the AI. So like we don't have to think, oh, there'll be killer robots roaming around. Like everything can be done. A lot of damage can be done using existing infrastructure. That's what.
Did you answer your question or the question? So I think, yeah, so what he was talking about is the AI boxing challenge. So this is an interesting thing where people think the AI is in a box, like on a server, and the AI can't leave. If it's in a completely secure box, it is safe, but not useful anymore. We need to expose some channel to talk to us at least. And the idea is that no matter how small of a channel you give it, we humans don't like to believe that they can be manipulated very easily. We like to believe we have free will, no one can control me. But the fact is, all of us are not that perfect. So, no matter what you keep here as a guard, it's a matter of, do you don't risk this? You don't have, it's possible to really manipulate the human to do what you want. It's also a possibility, and like, the point is that there's a lot of risks here. Like, people are really underestimating what could go wrong here. It's a completely unknown zone. And yeah, Adityaarpitha did actually escape the AI box. He tried to play the role of the AI, and he convinced people to let him out. And the rules of the game were very interesting. So the bet of money was there. So nothing else is there. I am a human being. He's inside the box. He just talk to me. Nothing else. I have to do nothing else. Just listen to him. And then after I think 3 hours or a couple of hours, 1 hour. 1 hour. Within 1 hour, if I don't let him outside the box, I get the money. Otherwise, he wins and he gets the money. I have to voluntarily say, okay, I let you out of the box. How did he manage that? He didn't reveal it. But I can understand why it was possible. And people generally seem to underestimate the degree to which they can be controlled. So anyway, that's the problem with exposing channels and the strength of AGI and
I think a simple way would be just that the AI promises when the person was guarding.
the wealth. Yeah, the thing is, human people don't really care. How can you believe that AI will actually follow through? Because if you understand this whole problem, you understand you can't really trust the AI will give you wealth.
AI could say, okay, I'm predicting the next market.
I think it might give like don't do anything for me. I just give you some tips. You do it, what make money. It's like free rewards, and he can then eventually once you get hooked to it, yeah, there are many ways. So the only thing is once enough people know about this, we'll be more careful about such systems. Maybe who knows? We'll try our best. This is the price. If you guys are interested, please do try it with the opportunity contest. These are examples of existing AI systems which are doing specification given. So when you train AI to do hide and seek, they found that the AI does box traffic. They realize that they can apply force to their own body. So they grab a box and they slide using the box and they capture the person. So these are sophisticated tools that AI is discovering within the simulation. Because what are we doing with science? We are discovering laws, physical laws, and leveraging them for technology, right? The same way, they realize the laws of their world were allowing them to do things like this, using RAMs as exploitation, They found an exploit which allows them to do endless running. And OpenAI released this on specification gaming, and I think it is pretty crazy. Like, there's an entire list of such things. Like, AI learned to crash the computer because at given points. AI learned to pause the game because at given points. So if you leave even a small loophole in your specification, if you don't design the reward system perfectly, if you have even one loophole, it will find it. Because what you tell it is exactly what it cares for. If you encode 5 of human's top values, the 6th top value will die. Because it will create a marginal improvement in the first 5 values for all the improvement in 6th value. That's how it thinks. It's a robots are dumb. So not say dumb. So the word dumb doesn't apply here. It's smart. But that is a also goal given. So this is a problem with specification when we are seeing it happening already with narrow AI systems. And there are many such examples. I'll share my slides if you guys want. With the entire list of such situations happening. And it all comes down to the problem of inner optimization. While your base optimizer is your stochastic gradient descent. You guys know enough ML. The model is your AI model. And what you're training is using the base objective. So what is your head rate? You put it into you make a mathematical formulation of what you care about. Be it like predict the best image recognition, do self-driving car, or win chess games, whatever you want. You design the base objective. And then the base optimizer will optimize the model by slowly varying the parameters using stochastic application in a very simple sense. And this optimization happens by looking at how it acts. You leave the model on a training data and you observe how it behaves in the training environment. And that actions, if it acts in a good way or in a bad way, if your cat picture is there, it gives probability of 2% of cat power. picture, we punish it and we move it towards a kind of model. So I would like to imagine a dart in a billion dimensional space, something like that, very high dimensional space, and you're moving it around and around until it becomes better and better at doing the actions. And in this process, it will discover its own Visa objective. Maybe it will start liking, it will start realizing that hey, these kind of patterns mean that it's a cat. For humans, we might see a different type of interpretation. But for the AI to be optimally good at what it does, it will have its own Visa objectives. And these are the things we care about, terminal goals. The terminal goals which vary us are the Visa objectives. And the inner alignment problem is, how do you ensure the base objective is same as the Visa objective? Because only if you train on every possible input, only then can you be sure that the Visa and the base are correct. Otherwise, it will always be out of distribution. Like testing error is all fine. You have overfit the data if you are memorize. But then training, when you generalize, when you show them certain examples and hope that it understands that. I mean, a better example would be when you reward an agent for winning the game, what does it learn? It learns all the moves that it played is good. It doesn't learn to value winning the game. It's learning something else. And it's something else called the base objective. And this is inherent problems that always happen where. So humans are the best example. Where our base objective by evolution, optimizing us, was genetic inclusive fitness and making maximum copies. We know this is the objective, but training stopped training kind of changed. We were trained from many thousands of years. And that's why we developed our base objectives. And our objectives right now, what we have, are a result of our training. So this is the environment problem. How do you use the training environment and the base objective to control the base objective? Very hard problem. There are a lot of issues there. And
Here, if there was perfect training, is it like in theory, if there was perfect optimization, the base and the Mesa would be exact?
no. So
But if you understand what objective is different from what we set for. But it's a
We set the base perfectly to match our human values. That is the outer alignment. But the inner alignment just depends on the training, right?
So if you give all possible inputs you could see, which is in the computer, but assume that it's computable and compute, and you keep training until it is perfect in that regard. So there's a complication here where what you're training for is behavior. So if you train it on all possible inputs, its behavior in all possible inputs will be aligned with the base objective, but its base objective might still be different. It doesn't functionally matter. Like if you care about ice cream and I care about chocolate ice cream, but we only see ice cream and no other ice cream, we both will keep eating ice cream. So inside I care about chocolate ice cream, you care about vanilla ice cream, but we both only see ice cream. We only see chocolate ice cream. So both of us will keep going and eating chocolate ice cream. So our behavior will always be aligned. It will be aligned with the base objective. But internally we are still not aligned. So the problem isn't solved, but it's a trivial solution because you don't have to worry. If behavior is what we care about, right? So hypothetically it wouldn't matter so much if we do that, but the problem isn't solved. But there's no point because it's like a brute force thing. You give every possible input, see every possible answer, and if it's wrong, we keep modifying it until it becomes good. Yeah, still does that. So you answer the problem, right? Like if the training environment isn't if the training environment isn't really capturing every single aspect of the base objective, it won't be forced to change the base objective. The base objective will only change if it is forced to change. Like it cares about what it should care about in order to perform best. So me caring about kids didn't make me have kids. Me caring about food and caring about pattern recognition and caring about these things made me like have kids. And before contraception, sex also mattered. So care depends on the training environment. So if the training environment is everything possible, I think then it will be aligned. If it's possible, then it will align. But again, it's all like not practically useful, but good to think about. This is my idea. I'm a junior researcher. I'm still entering this field, but this is the theory of how inner problems will happen. Is it clear? Any doubts? So yeah, I mean, I'd like to ask you to think about fire alarms. Like before we have a fire, we have warnings, right? So right now we already see AI doing multiple things. What is the thing that you think the weakest feat, the least impressive feat that you can think that AI will not be able to do in the next 2 years? Anyone have any ideas? Cannot. Next 2 years. And if you can give me like 9:1 betting odds. If you think you cannot do it, then you should be willing to, I'll give you 100 rupees. And if it happens, you give me 900 rupees. I'm not saying it's a joke, I'm not saying you should be, you don't have to actually do betting here. But it's a good way to really put your skin in the game. It's easy to say stuff like, I don't think it will happen. But if your money is in the game or if your actual reputation in the game, when you're forced to make a prediction, concrete prediction, then you feel more like it's actually going to happen. You feel surprised and scared. But we agree that right now we don't have AGI. We're far away from it. So what is stopping us from AGI? Like what tasks can humans do that AI cannot do right now? And you think that as far as you've seen with the current progress, for next 2 years, no way it's going to happen. Yeah, Vishma.
Can it make me a cup of coffee?
Like can humans do it? Something humans can do.
No.
Coffee.
Oh yeah, a cup of yeah.
No, it should.
This is called the Wozniak test. So Wozniak is a very, I think he's a computer games engineer, right? He makes.
I don't know.
But he made this test called the coffee test. He said he'll be really scared if the AI can walk into any random kitchen in any random house, find the coffee, find the sugar, make a nice cup of coffee and drink it. It's a thing that any human can, most humans can do. But right now AI can't do it. We are lagging behind a lot in robotics and such embodied intelligence. Our intelligence right now is all in servers and software. It's not in the robot form yet. So good. I mean, it's okay. So you actually would give 9:1 odds or no?
I mean, maybe, kind of. Yeah.
Really, 9:1. Okay, that's nice. And seems fair. But it's not the least. This is the least impressive. I think it's impressive. This is the weakest you can give me. Nothing weaker than this. How to identify a rotten apple? I think right now AI can do that.
Yeah, that's.
So only with image, no image, only with smell. So smell has enough sensors for smell. If we had sensors for smell, it would be very easy. Wait, smell is just compounds, right? Chemical.
Yeah, that's not a. Like, if you have the right sensors, then.
Yeah, I think it's an easy problem that we can solve. Because whatever knows us, it produces certain chemicals.
If you just have the right sensors for certain kind of like chemicals that are produced by a rotten egg, basically it is like infected with some bacteria or fungi. So whatever chemicals they produce, if you can detect that, then you can say that it is like rotten. You don't really need the smell.
Do you have an idea about the plant?
The least impressive feat I would bet 9:1 odds is if AI, which was like trained for text, can start producing, like, you just transfer the model and try to somewhere how make videos or like in a way that you can prompt images from the text, like not specifically training for from text to image, but using another model which generalizes to as an equally complicated task. Like that will be the least impressive thing that. Like, I believe like that would be the starting point after which it starts generalizing to more complicated.
So are you saying that it's only clear text, right? And you expect to be able to transfer them to videos?
Any kind of other,
So
other domain of
not text, with music.
yeah, maybe.
So already you know that how these models are trained only on text, was able to do mathematics. Word problems and even symbol manipulation, in fact it's still text. Yeah, I mean, I can think about it. I think it's a very impressive feat because they're giving it no information about, like, I don't know, I mean,
Like
it sounds very impressive.
walking into anything, and that's much more impressive than.
Oh, yes, it's like, okay, at least impressive. Seems fine, makes sense. But you think it happened eventually?
It should happen at least in like 10 years.
In 10 years. Okay.
He had some.
Precisely recognizing one or two words sarcasm.
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 Very like not a huge line, but like
So you think of some examples and you try it out after
Right.
this.
Oh.
I think you can ask me questions like, am I being sarcastic now? And give an example and it will tell you whether you're being sarcastic or not.
but would it be like accurate all the time?
I haven't tried sarcasm, but I'm very bad at sarcasm. I've tried code generation, explaining jokes. Sarcasm is a good thing to test. I tested things like
Even irony, like a lot of these complicated literary.
A metallic clanging noise is heard from a room. Which room is it? So it is able to understand from context that the room is kitchen because only kitchens have numeric plans. So I've tested like that, but sarcasm I'm pretty sure I won't be able to do. I think it will be very high. What accuracy would impress you? 90% or 80% or what accuracy of creating sarcasm would you be impressed by, or would you say it's
80% would be a good one.
so sarcasm would be different context, right? Like if humans detect sarcasm using the body language, tone of voice, and
Yeah.
just text. Do you find people understanding it based on
Yeah,
text?
I mean,
Because they know you
if you're
already.
chatting, if
Yeah,
you're chatting with
They
someone,
have a model of you already. Right? They
Yeah,
already
but-
spend time with you. They know the kind of person you are.
No,
they have
even if it's a
bias.
stranger, if you
Yeah.
say something like "yeah, right," like if you just type "yeah, right," they'll understand it's sarcasm based on context.
The model like
It is
this
a
would have
cultural
learned
thing,
that, yeah, right.
Yeah, it is a common thing here. Yeah, right. Okay, in our head we hear it like that.
Yeah.
You try it. Yeah. You try it.
Or if you say something like "right," it like it's somewhere in between "right" and
I think you give it like a series of conversation. Right? Take some conversation with your friend, take all the messages, and ask, is this line sarcastic? I think you understand. I think. Well, it's a good test.
No, but what if we say like what lines are
Now,
sarcastic?
which line is sarcastic? Line 1, 2, 3, 4, give it like that, and then
It needs
ask
to
which line is
identify,
sarcastic.
yeah.
It's complete. GPT-3 is insane, and you guys have to try it. It's open source, it's free to use. Go to OpenAI's website and play with it, chat with it, ask questions. It will explain things like, it has so much knowledge. So,
Maybe from that answer, that's something important.
look, asking the questions is very important, like how you. So, the idea is if you train to complete the next sentence, next word, next word, next word. So, you have to think about structuring in a way where the next word is automatically the answer. So, what mostly fits. So, right now at this point, it's important how you structure. Like, for example, if you give it some examples of what you want, it does suddenly a lot does not work. Like, a few prompt answering is better than zero shot. And it also seems to be better if you give it this thing called please listen step by step. Forcing you to listen step by step improves accuracy and various tasks. So, just to conclude my talk, I've taken up so much of your time. Thanks a lot for sitting with us. And we're going to talk about how we are living it at a very crazy time. Whatever essays you have about the world, about the past, the future is changing. Think about how much when life starts out on Earth. In 5000 BC, we had first sailboats. Around 1000 sorry. And 1700 we had steam engine. Around 1800 we had first programmable digital computer. AI started in 1956, and we are now here. So it's hard to comprehend how fast things have changed. So our existing models aren't going to likely stay continue their predictive power when you are living in this period of time and things are the curve is asymptotic. We are not in the small linear growth phase. Things are moving rapidly. Think of this is the graph of world GDP. You are at this point right now. We are at the peak and it's exploding upwards. It's a crazy time to be alive. This might be the most important century of humanity. Not just because of AI and AGI and stuff. There are other risks we have. We have climate change, we have political issues, we have resources constraints, like water table is going down, weather is going crazy. We have so many other issues. doesn't seem like the current pace is sustainable. What we are going right now, everyone has this feeling like things can't go on like this. We need to change things to make it sustainable. We need to, because we can't exponentially grow forever. It's not sustainable in the real world. We can't keep growing. We need to reach a plateau, or we need to go down, crash and collapse, or we need to maybe, I don't know, change the way things work. So there's a very important case to be made. This is the most important century. So just to wrap up my talk, there are a lot of economic incentives to develop AGI. Top companies like DeepMind and OpenAI are openly trying to develop AGI. The timelines by experts and by various reports look 30 years, 20 years, 50 years, 100 years within our lifetime. Alignment is a very, very hard technical problem. We would love people to work on it, spread awareness, get people to see our funding. There is a lot of job in there. Very smart people, IITs, or the CMI, other people from Google to work on this topic. And even if you don't buy into those entire, I've tried to make convinced this is a problem we need to work on. Even if the problem is very small, just understand that the impact is so large, such a big claim, that even with a very low probability, it is worth considering it seriously. Like tsunami happens once in 100 years, we still plan for it. Disasters are happen very rarely, but we still take a lot of precautions because of the outsized impact it has on our millions of people. This I'm talking about is crazy and is affecting the entire world. So we need to be very careful and fearful when we go to a new domain. We can't take it casually. So please do think about these arguments and spread the word. Now what can you do? Let's see.
Was accessibility shortcuts.
Let's see what we can do. So yeah, don't buy into arguments blindly. Argue, discuss, debate, consult the conversation, convince people who are already into this debate. Maybe we are wrong. Maybe there are some things we haven't understood. So read more conversations. You can spend a month of your time trying to upskill and learn more. Maybe get a copy of this book, Alignment Problem by Brian Christian. If you want to know about how your career and your time can be spent with putting an impact, there's a website called 80,000 Hours, and you can use that to get counseling for get finding a job that will make a huge impact. So that's pretty much the syllabus for upskilling and learning. This is the current number of people working on AI safety, 300 people in the world. There are so much more people working on AI capabilities research, trying to build better AI systems, smarter ones. No one's working on safety. We definitely need people. So you can study all these really cool skills, which will help you in other areas also, like mathematics and computer science will help you in other jobs also. So safety is a very interesting field, interesting problem, has a lot of potential. And this is the AGI Cambridge Fundamental Syllabus. Any questions? Otherwise, we'll wrap it up. I like it. I wasn't very big fan of capabilities because
capabilities are rewarding.
no, I mean capabilities felt like a black box. Like I didn't like the fact that AI is just a black box. I like more mathematical stuff. I was working on in PhD in stochastic differential equations and trying to use actual mathematical tools to solve problems. But we have like the elegance of mathematics is lost a lot when you just use architecture and then just put training network. So it's just so I didn't like capabilities personally. But then I became scared about this year when I heard really good arguments about why people are having a blind spot about this issue. Our culture makes us not take this seriously. We are brought up to think of, oh, nothing bad will happen. But world ending will never happen. It can happen. The typical COVID will happen. It will happen. Yeah, world war or even now people are talking about nuclear war. Things can happen. These things have happened and will happen. So we should be very careful about this. So that's why I started taking it seriously. And I'm still figuring things out. Like I haven't 100%. And my hope is by going to talk like this, you will tell me. You ask me, here are great questions. Like anything. Maybe I'll go and think about it. Does death actually something that we have to instinctually know? Or is instrumental convergence really a thing? So that's why I'm still learning myself. I think we need a conversation around this because we are building a tool which we don't understand. And it's not moving. And that's something very scary. So that's what happened. Any questions? Feel free, guys. You always meet me after the talk also. And in case you guys want to give me some feedback, you get a free book. You get a free book sent to your address. You can take from the 11 problem, for example, one of the books I'll be giving. Right, just go to book.ly and it's like a hard copy I got. So you can check it out if you want. And give me some feedback on the talk. And if you want to talk to me in the future, I'm interested in AI safety. You can contact me at my website, phone number, WhatsApp, Instagram, Twitter. I'm like, they're on social media. And we can book a slot to discuss more. You know, I'm doing in Bangalore. And then I'll be going to Oxford University next on 4 days for a workshop. So I can still talk to you from there. The earlier we start, the better because timelines might be short and it will take time to upskill yourself in these domains. So, those of you watching from YouTube, start immediately and start learning. So, yeah, if you give me feedback, that will be great. And if you guys don't want to give me feedback, then you can still go to his website and get the free book. And then it's fine. Books are always good. So go to the website, effectivealtruism.org, and click on request a free book, enter your address and name and everything, and you can get a free book. I recommend the 11 problem if you're into what do you call it? If you like the ASAP aspect. I recommend the 8,000 hours if you're into maximizing the optimal career, thinking about what your career suits you. The principles is more about if you want to think about other risks, like why is AGI risk so much more important than say bio risk or the risk of nuclear war and things like that. Doing good better is more about effective altruism and what it's necessary. All are good books. And I modeled one. I got the lemon novel. Nice copies of the name. So that's, I think, that concludes my talk. And if you guys want to stay back, talk to me and all, I'd be happy to have that. I wonder how much time I took. It's
7.
7.
Yeah, yes.